Hello all, welcome back to my YouTube channel all about VLSI. In this particular video, we are going to start our discussion about I-type instructions. So basically, I stands for immediate operations, and in our RISC-V, we have different kind of instruction formats. And in our previous session, we have discussed about R-type instructions. Now, in this particular session, we are going to discuss about something known as I-type instruction format. Now, coming to my I-type instruction format, I basically stands for immediate operations, where in the instruction itself I'm going to provide an immediate value, whereas in the case of my R type instructions I was not providing any particular immediate value in the instruction itself. I was basically providing the register offset addresses, that's it. But here in the case of my I type instructions I'm going to provide the immediate value in the instruction itself. Now, so let us try to understand what we are going to discuss in this particular session. We are going to discuss what is an I type instruction, and we're going to discuss the 32-bit encoding layout, what exactly each field is going to convey us, and we are going to discuss each and every particular field, and we are going to see what are the different kind of I-type instructions we are going to have, right? So coming to what do you mean by an instruction and all, we have already discussed in our previous session itself. Now, coming to this I-type instruction, which is of immediate type, is one of the six base instructions format in RV32I, and it is going to encode operations that read from one source register and a constant embedded in the instruction itself. So, for example, you can see here this is an immediate instruction which is add I. I'm going to have X5 is my destination register, and this is one of the source register RS1 and your immediate value. So in the case of your I type instructions, you have an option basically to add the content which is present inside your register with the immediate value. That is what we are going to do over here. So this is nothing but my opcode and followed by destination register, and this is one of the source register, and this is the immediate value. So every I type instruction is exactly 32-bit wide and use it for arithmetic logic unit, immediate opcodes and loads and jump and load and system calls, and any particular operation needing a constant baked into the word. So this is what my I type instruction is. So basically, and coming to the key properties of this I-type instructions, one immediate field, a particular constant value lives inside the instruction itself, as I have said you previously, and only one operand RS1 comes from the register file, and the second operand immediate is baked directly from the instruction word itself, and it is basically different from our our R-type instructions that I have said you already. Now here, this particular immediate value, it is a 12-bit immediate, and it is sign extended to 32-bit because here RS1 is going to have a 32-bit value, right? So that's the reason this immediate value is actually 12-bit only, and this will be converted into sign extended 32-bit value, and the operations will be performed on this sign extended 32-bit value, immediate value, and the registers 32-bit value. So that is the reason the ALU uses it, so it can represent from minus 2048 to 2047. So immediate 11 down to 0, as I've said you, this is not an address, it's the actual value which I'm going to use. So a 12-bit immediate is the actual operand, and unlike RS1 and RS2 and RD, which are basically the register indexes, my immediate value is the actual index or actual data which I'm going to have it in the instruction itself. So basically, this immediate value never carries an address, it carries the value itself, and it is basically sign extended to 32 bits before reaching the ALU, and the same encoded instruction always adds the same constant run after run. Okay, now this is about my immediate value. Now let us try to understand what is it exactly that 32-bit register content is telling me. I type instruction is basically telling me, as we have already seen, from 0 to 6 it's an opcode for every particular instruction. It may be an R type instruction, or it may be I type instruction, or it may be S type instruction. You can take any particular instruction, opcode is fixed to the LSB. That's it. From 0 to 6, it is LSB of 7 bits. Next is destination register, which is of 11 down to 7, which is of 5 bits. And next is function 3, which is of 3 bits. And next is RS1, which is source register, which is of 5 bits. And next is our immediate value 11 down to 0, which is of basically 12 bits. So this is my instruction format, which I'm going to have in the case of my I type instruction. Now, as we have discussed in the case of my R-type instructions, the opcode is going to play a key role for basically understanding the kind of instruction family. So here also opcode is going to basically tell me what kind of instruction it is. And RS1 is my source register one, and immediate 11 down to 0. As I've told you, it's a 12-bit constant value, and it is further sign extended to 32-bit before we are going to use it. And RD, as we have already seen, it's a destination register. Whatever the result of this particular RS1 and the immediate value, that will be stored inside my RD register. Next is function 3. It is going to, basically select what kind of operation which we are going to do in our I-type instruction. That is what we are going to check it out. Now, so as I've said you, opcode is going to basically identify the instruction family, and next is destination register. Next is function 3. It is going to basically tell me what kind of operation I'm going to do in the case of my I-type instruction. And RS1 is my source register, and immediate 11 down to 0 is a sign extended immediate value, which I'm going to basically perform the operation between these two fields. Now, depending upon my function 3, I'm going to decide what kind of operation I should perform. Now, in the case of my add I instruction, my function 3 is equal to 000. Now, the operation is destination register is equal to source register plus sign extended immediate value. So, whatever the immediate value which will be provided, right, that we are going to add it with my source register. And in this particular shift left set less than immediate, here we are going to compare this to, and if this condition is satisfied, then we are going to provide this equal to 1 or provide this equal to 0. This is nothing but my set less than, and this is set less than unsigned, and I'm going to have an XOR operation, or operation, and operation, and shift left immediate, and shift right immediate, and next I'm going to have shift right arithmetic, and this is shift right logical, and this is shift right arithmetic. So this is the operations which we are going to use in the case of my I-type instructions, and these are the different kind of operations which we are going to do in our I-type instructions. And next, we are going to try to understand the difference between our SRLI and SRAI, where SRLI is nothing but shift right logical, and SRAI is nothing but shift right arithmetic. So one shared opcode and function 3, a single immediate bit is going to tell me is going to basically differentiate between them. So you can see over here, SRLI and SRAI are going to share the exact opcode, which is nothing but 00 100 and function 3, which is equal to 101. You can see over here we are going to have, and give me 1 second, and here uh, if you can observe over here, in the case of my SRLI and SRAI, I'm going to have the same function 3 values, which is 101. So in SRLI also I'm going to have 101, and in SRAI also I'm going to have 101. So both are going to have the same function 3 value, but how we are going to differentiate between these two operations? By using the immediate value. So using this particular immediate value, we are going to basically differentiate between an SRLI instruction and an SRAI instruction. So that is what it is written over here, right? Now, so let's say if I'm going to perform add operation, immediate add operation between these values x6 and the immediate value. So what is my opcode? This is my opcode, and next is this is my destination register, and this is my function 3 and RS1 and immediate value. So this is how my instruction is going to look like, which is an add I immediate value instruction. And where is I-type instruction is used? It is basically used in your reg underscore read. So only RS1 is going to index the register file. The immediate value needs no lookup. It is already present in the instruction itself. Only in the reg underscore read stage, we are going to go and fetch our data which is present in our register. So in this particular session, we have discussed about I-type instructions, and we have discussed about what are the different 5 fields which I'm going to have, and how function 3 and immediate 11 down to 5 is going to decide a particular operation or differentiate the operation. And we have discussed about different kind of operations. Next, we have seen about difference between SRLI and SRAI. So yeah, so that's about this particular session. If you have any queries or any other particular doubts, you can comment in the comment section. So if you like this video, please like, share, and subscribe to my YouTube channel all about VLSI. Thank you for watching this video.